Okay. So after thermal properties, the next topic which we are studying is heat transfer. So in the name itself we can understand, no? So how heat can be transferred from one body to another body or from one place to another place. Okay. So heat can be transferred in three methods. Clear? First one is called conduction. Second one is called convection. And the third one is called as radiation. Okay. So in these three methods, heat can be transferred from one place to another place or from one body to another body. Clear now? So what is meant by conduction? We will study each of them briefly, then we will study each of them in a detailed manner. So first of all, you write down conduction. Conduction means transfer of heat when two bodies are in contact. Okay, ma? Here, medium does not move. Only energy travels. Okay. So it is the slowest process. Okay. So this is a brief explanation about conduction. Understood, no? So in which condition heat will transfer in conduction? Two bodies, they must be in contact with each other. Clear? And the medium doesn't move. That is, the particles of one medium doesn't travel from one place to another place. They are in their same position. Okay. So energy travels only by vibration, means that is one particle vibrates and it gives its vibrational energy to the next particle. So like this heat will transfer. So this process is the slowest process. For example, for example, if I take an iron rod, clear? So this iron rod is made up of iron atoms, no? Okay. And these iron atoms, they will be vibrating along their mean position. Already we have studied that any particle, any medium or any particle of any medium, always it will be vibrating around their mean position if it is a solid body. So if I supply heat energy to this rod, at one end of this rod, I am supplying heat energy. So heat is a form of energy. So therefore what happens? Therefore, this molecule which receives the heat energy, it starts vibrating with a greater amplitude. Okay, ma? It starts vibrating with a greater amplitude. The amplitude of vibration increases. Okay. In that process, it gives its energy to the next atom or next molecule. Are you able to understand, ma? Because it is vibrating by a very large amplitude, it will go and collide with the next atom. So next atom also starts vibrating with a greater amplitude. And this particle again, it gives its energy to the next atom. Okay, ma? So therefore, vibrational energy, heat energy is converted into vibrational energy, and that energy is again supplied to the next atom. So like this, heat will be continuously transferred from one place to another place. Are you able to understand? So here what is happening? Bodily movement of particles, is it present? Particles, are they moving? No, they are present at their mean position or vibrating across their mean position, and vibrational energy is being supplied to next atom. Are you able to understand? So like this, continuously heat travels from one end of the rod to another end of the rod. I am not discussing about bodies. First of all, we discuss about particles. In one particle, this is how heat energy travels. Similarly, same concept you can study with the help of two bodies also. For example, this is one body, this is another body. Clear, no? So the particles which are present here, they are vibrating along their mean position, and they will give the energy to the next particles which are present in the second body. Are you able to understand? Point is that here, medium doesn't travel. Particles, they never travel. They are present in their mean position. But still energy is transferred from one particle to another particle with the help of vibrational energy. Are you able to understand? So therefore, this process will be the slowest process in all the three processes of conduction, convection as well as radiation. Are you able to understand? So second method of transfer is called convection. Okay. Let us have a brief idea about convection. What is meant by convection? Okay. So here, heat travels by bodily movement of particles. Clear, Nama? So here particles, they travel from one place to another place and they give their energy to the next particle. Are you able to understand, ma? For example, if I take water, okay, ma? And if I start heating water, for example, if I start heating water at one end of this tank, then the molecules which are present here, they get this heat energy, no? The molecules which are present in this region, they don't get any heat energy. But the particles which are present at this end, they receive the heat energy. Once they receive the heat energy, what happens to the density of water? Density of water reduces, because anything expands on heating, no, volume increases. If volume increases, what happens to density? Density reduces. So therefore what happens is, these molecules, they start moving upwards. Okay? And what is the temperature of this molecule? Temperature of this molecule is very large, because it is receiving heat energy from this heater, no? Are you able to understand, ma? So temperature of this molecule is very large, and because its density has reduced, it starts moving upwards. But surrounding this molecule, there are many cooler molecules, no, ma? So this energy will be transferred to the cooler molecules. Okay? So by the time it reaches to the highest position, its temperature will be lesser when compared to the temperature present at this position. Are you able to understand? So what happened to this temperature? The energy has been received by surrounding molecules. There are many molecules which are present at the side of this molecule, they will receive the energy. Are you able to understand? And here it cools down, so again it travels like this, again it enters, and again it reaches to the initial position. So it means here molecules are traveling by which method? Molecules are traveling, actually they are traveling. Okay, ma? And in the process of traveling, they are giving their heat energy to the cooler atoms or cooler molecules. Are you able to understand, ma? So this method of transfer is called as convection. Okay, so therefore here we write, it is a fast process compared to what? It is a fast process compared to conduction. Are you able to understand, ma? And then we study about radiation. So what is meant by radiation? So transfer of heat energy without any medium. Okay, ma? Medium is not at all required for this radiation. Okay? So we are receiving heat energy from sun, no, ma? So sun is present at lakhs of kilometers, but still earth is receiving the heat energy. But in between earth and sun, is there any medium? There is no medium, but still we are getting that heat energy. So that method of heat transfer is called as radiation. Are you able to understand? So here conduction and convection, they require medium for their traveling. Okay? In conduction, you must have medium. This is a medium, no? Iron rod is a medium. Okay? And in a convection also, definitely medium is required. Only for radiation, you don't require any medium. Medium is not required. Okay? Why? What is the reason? Because heat is converted into electromagnetic waves. Okay, ma? And when these waves strike the surface of any body, then again electromagnetic waves are converted into heat. Are you able to understand, ma? So at the surface of the sun, what happens is, heat energy, it converts into electromagnetic waves, ma. Okay? What is meant by electromagnetic waves? Light is a form of electromagnetic wave, no? X-rays, gamma rays, radio waves, microwaves, all these are electromagnetic waves. And electromagnetic waves does not require any medium for traveling. Are you able to understand? So therefore, at the surface of the sun, this heat energy, it converts into which energy? It converts into electromagnetic waves. And they travel through the space with the speed of light only. So what is the speed of electromagnetic waves? Speed of light, 3 into 10 power 8 meters per second. So with that speed, they reach the surface of the earth. And once they strike the surface of the earth, again these electromagnetic waves, they will be converted into heat energy. Okay? So therefore, this method of heat transfer does not require any medium. Are you able to understand? Whereas these two, definitely they require medium for their travel. Okay? So make a note of that point. So note point is what? Note point is that, okay, conduction and convection require medium for transferring heat energy. Okay, ma? Whereas radiation doesn't require any medium for transferring the heat energy. Understood, no, ma? That's it. So make a note up to here. Okay, so see, ma. So So in all the three methods of heat transfer, first of all, we are studying about conduction. Okay, SEMA. So consider this is a rod, an iron rod, whose initial temperature is how much? Let us consider its initial temperature is 30 degrees Celsius. Are you able to understand? This is the initial temperature. Now one end of the rod, it is placed in a tank where water is present at a temperature of 100 degrees Celsius. Are you able to understand, ma? And the second end of the rod is placed in another container in which ice cubes are present at 0 degrees Celsius. Are you able to understand, ma? And this water, I am heating it continuously. Initial temperature of water is 100. Are you able to understand, ma? And still I am heating this tank in which water is present. I am heating that water continuously. Okay. Then can you say, what are the changes which will happen? Anybody, can you say, ma? Ice starts melting. Why ice starts melting? Heat energy travels from one end of the rod to other end of the rod, and we see that slowly the ice starts melting. Are you able to understand, ma? But before that thing, what happens is, let us see. For example, this is a rod. Are you able to understand, ma? Initial temperature was 30 degrees Celsius, no, before it was placed in these two tanks. It means everywhere. If you check here, 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 anywhere if you check, temperature is how much? It is 30 degrees Celsius. Are you able to understand, ma? But as soon as I place this rod in this water of 100 degrees and ice at 0 degrees, then what happens? Immediately what happens is that, clear, ma? One end of the rod, it will be suddenly at 100 degrees Celsius. Clear, no? Other end of the rod, suddenly it will be at 0 degrees Celsius. This is what will happen, no? Clear, no? But what about the middle part of the rod? It will be still in 30 only. Are you able to understand? So this is what I am observing immediately when I place the rod. Okay. So immediately when a rod is placed in tanks. Are you able to understand, ma? Then what happens then? 100 is at a higher temperature number when compared to 30. So slowly heat energy starts traveling from 100 to 30. Clear, no? And from 30 also heat energy starts traveling from 30 to 0 degrees Celsius. Then after some time we observe that temperatures of each section of the rod continuously they will change. Are you able to understand? So therefore after some time what happens is, this will be the respective temperatures of the rod. So here you can find a temperature is 100 degrees Celsius. Then here you can find it is 80 degrees Celsius. Here you can find somewhere 60 degrees Celsius. And here you can find somewhere 40 degree. And here you can find somewhere 20 degrees Celsius. And here you can find it is 0 degrees Celsius. Are you able to understand? After some time, this will be the temperatures of the rod. Are you able to understand? But still we are continuing heating this one. Okay, we are continuing to heat this water which was present at 100 degree Celsius. Now what about the temperature of this water? Temperature of this water, will it change? Temperature of this water will never change. Why? Because the boiling point of water 100 only. No, beyond 100 you cannot heat water. That is called boiling point. No? Beyond 100 you cannot raise the temperature of water. This is boiling point. No? Here water starts converting into steam. Temperature of steam you can change. Are you able to understand? But water temperature remains to be at 100. Then what is happening to the total heat energy? Some of the heat energy is transferring in the rod, and some of the heat energy may be useful for converting this water into steam also. Are you able to understand, ma? So after some time we see that temperature of each section of this rod is this much. Okay, and then afterwards whatever may be the heat energy you are supplying, clear, these temperatures will never change. You are supplying heat energy, but still temperatures they will remain to be same only. And this state is called as a steady state. Are you able to understand, ma? So what are these states? These are variable states. Variable states means temperatures they are changing continuously. Are you able to understand, ma? But after certain interval of time, temperature of each section of the rod, it will remain constant. Temperatures are not same. Okay, ma? Temperatures are not same. Here it is 100, but here it is 80. But 100 remains to be 100, 80 remains to be 80, even after any amount of time. So this state of the rod we can call it as steady state. Clear, ma? So write down. This is what this is called as steady state. Okay. So therefore what is the note point here I have to write? Note point is that after some time after some time, each section of rod attains a constant temperature, okay ma, and each section will maintain the same temperature, okay ma. This state is called steady state. Are you able to understand what is meant by steady state ma? So after steady state, temperatures of each section of the rod, they are not going to change. They will remain to be constant. Okay? Clear na ma? That state we can call it as steady state. So then afterwards, we will study a very important term which is called as temperature gradient. Okay? Completed writing up to here? Make a note. Idhira notes. Itla cheyaddu next time. Notes raskondi. Khaliga. Okay ma. So then what is meant by temperature gradient? Let us see ma. So temperature gradient is equals to, how can I write? For example, let us take these two temperatures ma. These two temperatures, they are separated by distance of x, no? Clear no ma? Here there is a temperature of 60, here there is a temperature of 80. Okay? And these two temperatures, they are separated by distance of x. X can be anything. Clear? So therefore I will write 60 minus 80 divided by x. This ratio is called as temperature gradient. It means how temperature is changing per unit length of the rod. Temperature 60 minus 80 means temperature difference only, no? And x means what? Distance between the 2 points. Are you able to understand? So change in temperature per unit length of the rod is called as temperature gradient. This I can also write it as minus d theta divided by dx. In differential form I can write like this. Are you able to understand ma? So therefore what is the meaning of temperature gradient? Temperature gradient is nothing but how temperature is changing with respect to distance between 2 points. Clear? So if temperature difference is greater, then temperature gradient also will be greater. Understood, Amma? Here there is a temperature difference of only 20. If temperature difference is greater, numerator increases, no? If numerator increases, temperature gradient also increases. So that ratio is called temperature gradient. Okay? Okay, ma? Now see. So the next concept which we are studying is the coefficient of thermal conductivity, ma. Okay? Now see. So this is a body, or you can call it as any cuboid. Are you able to understand, ma? So this is one face of this cuboid. This is another face of the cuboid. Total we have 6 faces for a cuboid, no, ma? So we are discussing about 2 faces. So this is one face and this is another face. So cuboid means the opposite ends, definitely they will have same area of cross section, no? So cross section of this area is A and cross section of the other side is also A only. So this side is also having same area of cross section A. Clear? So temperature of one face is T1, temperature of another face is T2. Not a PHASima, face, FACE, face. So there are 6 faces of a cuboid, no? Yeah? So this is at a higher temperature, this is at a lower temperature. Then heat energy will transfer from which phase to which phase? Heat energy will transfer from first phase to second phase. So this is the direction in which heat energy will flow. Understood, Nama? Because heat naturally, it flows from a body of higher temperature to a body at lower temperature. Clear, Nama? So this amount of heat transferred is directly proportional to temperature difference T1 minus T2. So this is one point which you should remember. Understood, Nama? What is meant by Q here? Q means heat energy. Chappanda Panakona chinare appude open chesi cheppandi noru. Q means what? Heat energy. So heat energy is directly proportional to temperature difference. It means if temperature difference is greater, then more amount of heat energy will transfer. This is understandable, no? If temperature difference is very less, then the amount of heat energy transferred also will be lesser. But if heat energy temperature difference is greater, more amount of heat energy will transfer. Similarly, the amount of heat transferred is also directly proportional to time of travel. Okay? If you take lesser time, lesser heat will transfer. If you take more time, more amount of heat will transfer. This is also understandable, no? Okay, ma? See, ma, heat flow, current flow and water flow, all of them they are same. Okay? Flow of water, flow of heat and flow of current. Almost they follow the same principles. Understood? No? See, for example, if you take 5 amperes of current which is flowing here, okay, then here 3 amperes will be distributed and here maybe 2 amperes may be distributed. Clear? Same concept I can say with heat energy also. For example, 10 joules of heat energy is traveling per second through this rod. 10 joules of heat energy if you're traveling per second. So in this one, 5 joules of heat energy may travel, and here also 5 joules of heat energy may travel. Understood? No? So here if I say 10 liters of water is flowing per second, then here 5 liters of water can flow per second, and here 5 liters of water can flow per second. Understood? No? So water will be distributed. No? Similarly, current also will be distributed. Heat also will be distributed. Are you able to understand? So this is one very important point which you should make a note. Note is what? So heat to flow, current to flow, and water flow have similarities. Okay? So what are the similarities they have? Already we have studied. No? Some more similarities we will study in the upcoming time. Understood, Nama? So therefore, if you take more amount of time, then more amount of heat energy will travel. No? For example, you are taking a pipe and you are planting water to a plant, watering water to a plant. So if you on the pipe for more time, more amount of water will flow. Same concept here also. Understood, Nama? If time taken is greater, then amount of heat transferred also will be greater. Similarly, Q is directly proportional to area of cross section. Okay? What is meant by area of cross section? So this is one phase, Nama, which is the phase here. This is one phase. This is one phase, no? Understood? So if this area of the phase is increased, definitely the amount of heat transferred also will be increased. Okay? So more amount of heat can transfer in a wider rod when compared to narrow rod. Okay? Area of cross section increases, more amount of heat will transfer. Similarly, Q is inversely proportional to 1 by length or x, L or x, anything you can write. Are you able to understand? Ma? And what is meant by L here? Distance between the two faces. This is also understandable. No? If distance between the two faces increases, then the amount of heat transferred will be lesser. Okay? So the amount of heat transferred depends on these 4 factors. Okay? Directly proportional to 3 factors, inversely proportional to 1 factor. Are you able to understand? Ma? Now if I combine all of them, then I can write all of them in a single equation. No? What is that equation, can you say? So I can make the equation like this. I can write Q is proportional to T1 minus T2 into A into T divided by L or X. This is how I can write. Understood, no? The amount of heat transferred is directly proportional to temperature difference, area of cross section, time of travel divided by distance between the 2 points. Understood, no? Now to remove this proportionality symbol, I have to place a constant, you know, and that constant is exactly what is called as the coefficient of thermal conductivity, and it is represented by the letter K. Okay, ma? So therefore, what is the equation I can write? Equation is Q is equals to K T1 minus T2 into A into T divided by L. Okay, ma? This is the equation to calculate the amount of heat energy transferred between 2 ends of any body, or 2 ends of a rod, or 2 ends of a cube, 2 ends of a wall, anything. Clear, ma? That's it. And see here, this K value, it depends on the nature of the material, ma. K value depends on what? It depends on nature of the material. So some materials have higher K value. It means heat energy can be transferred very easily. Okay, ma? If K value is lesser, heat energy cannot be distributed easily. Okay, so let us make a note of that point also. Okay, ma. So write down. K value depends on, K means coefficient of thermal conductivity, ma. Okay, ma. K value depends on what? Depends on nature of material. Okay. So for some values, K value is bigger. For some values, K value is smaller. So therefore, if K value is bigger, can you say what happens, ma? Completed, no, this one? Okay. If K is bigger, heat is transferred more easily. Okay, ma? Or we can say distribution of heat energy will be effective. Okay, ma? Heat energy can be distributed very easily, ma, if Q value is greater. Okay. For example, let us take one practical example, ma, in daily life. K value of aluminium is greater than K value of steel. Okay. This is one point. See, ma, we cook food materials in two types of vessels. No? Either we use aluminium materials for cooking, or we use steel materials for cooking. Are you able to understand? So instead of steel, we prefer aluminium for cooking. In our households, most of the households, you should see aluminium only, no? Aluminium is preferred for cooking. What is the reason? Its K value is greater. Are you able to understand? So heat will be transferred more easily in the case of aluminium. So how we cook vessels, ma? Okay. So for example, if I take this as one vessel in which we are cooking some rice or some curries, so here we are heating this one. Are you able to understand? If it is an aluminium vessel, then even though you are supplying heat energy here, at the base only we supply heat energy, no? But heat will be transferred throughout the surface area of this container very easily. Okay? Because heat is transferred evenly, so there is a chance of food getting cooked evenly. Even cooking of food we will get. Okay? But if you take a steel vessel, okay, ma? If you take a steel vessel and if you start cooking the food, then what happens is total heat will be concentrated here only. Are you able to understand, ma? And heat, the amount of heat transferred to other surface areas, it will be very less. Are you able to understand? And most of the heat, it will be concentrated at the point where you are heating. So therefore what will happen? Food cannot be cooked very easily. Okay? So steel lo meeru annam ondina biryani lo ondina ikkada mottham idi maadipotundi. Clear? Why? Heat energy is not able to be distributed very easily. That is the reason. Are you able to understand, ma? But still you have to prefer either cooking in steel or earth parts, ma. Are you able to understand? Because if you start cooking in aluminium vessels, so male people, they will lose their sperm count, and women, they will lose their ability to reproduce. So these are the biggest disadvantages of cooking in aluminium vessel. Are you able to understand? Me prati intlo ave untai, aluminium untai. Are you able to understand? The reproductive system will be completely damaged if you cook the food in aluminium. Okay? Okay? Sima. This is the question which he is asking. So a refrigerator door is 150 centimeter high. It means height of the door is 150 centimeter and width of the door is 80 centimeter and thickness of the door is 6 centimeter. So K value is given 0.0005 calories per centimeter per second per degree Celsius, and inner and outer surfaces are at a temperature of 0 degrees and 30 degrees respectively. It means inside the refrigerator, what is the temperature? 0. Outside the refrigerator, temperature is 30. Then how much heat is lost per minute through the door? That is the question. Clear number? It means here instead of block, previously we have taken one cuboid and we have done all the values number. Here instead of cuboid, what we will take? Door. Door is the body. Clear, no? So consider this is the door of a refrigerator. So what is the length of the door? Length of the door is how much, ma? Length of the door is 150 centimeter. And what is the width? Width of the door, I don't know. That I cannot say. I am doing only two-dimensional figure, no? So length is 150. Width is how much? 80 centimeter. And what is the thickness of the door? Thickness of the door is 6 centimeter. Then how much heat energy is lost per minute? Already we have written equation, no? Q is equals to Ka into T1 minus T2 into T divided by L. This is the relation. Okay? So Q, and what is the time he said? Time he did not say in 1 second, he said in 60 seconds, 1 minute. So therefore T you have to take as 60 seconds. Understood, no? 1 minute only he said, no? Heat loss per minute. Okay, so inside of this refrigerator, what is the temperature? 0 degrees Celsius. And outside this refrigerator, temperature is 30 degrees Celsius. Are you able to understand? So therefore, heat energy travels from which side to which side? Heat energy travels from 30 degrees to 0 degrees. So this is the direction in which heat will transfer. Are you able to understand? So therefore, do the calculation. So amount of heat energy traveled is equals to, K value is how much? 0.0005 multiplied by, area means which area we have to take, ma? Area of cross section. Can you say what is the area of cross section here? This is a door, no? If I look from this side, how door appears like? This is how door of the refrigerator appears, no? So height is 150, clear, no, ma? And what is the width of the door? Width of the door is 80 centimeter. Area of cross section is nothing but length into breadth, no? This will become the area of cross section. So 80 multiplied by 150. Now what is the temperature difference? 30 and 0. So temperature difference is 30 multiplied by time is 60 seconds divided by L means what? Heat. Anything you can write. I want heat energy only, no? 0 minus 30 you can write, 30 minus 0 both are same. Are you able to understand, ma? Now this is the width through which heat energy will transfer, no, ma? 6 centimeter. So 6. So just do this calculation, then I will get the total amount of heat energy which is transferred in a time of 1 minute. Understood, no, ma? And the answer is, you will get temperature difference కావాలరా నాకు. 0 minus 30 ఎంత? 30 minus 0? Magnitude 30నే కదా? నాకు కావాల్సింది అదే కదా. Okay? Heat energy is a scalar quantity, ma. It is not a vector quantity. Energy scalar quantity కదా, మరి మైనస్ ప్లస్తో నీకేం పని రే? రైట్. క్లియర్ మా? సో Q is equals to 1800 calories. That is our answer. Understood, ma? Okay, ma. So let us see this question, ma. So see here. So door of a refrigerator is 90 mm thick. It means thickness of the door is given, ma. Okay. And what is the area of the door? Area of the door is 5.6 meters square. And the temperature difference between where and where? Surroundings and the inside of the temperature. So temperature difference is 22.2. Now the problem is motor of the refrigerator runs for 15% of the time. Okay, ma? So you should have seen refrigerator motor will on only for some time only, no? After that it will stop. So motor is running only for 15% of the time. Then the question is, at what rate must the heat be taken from interior while motor is running? So I want to maintain temperature difference of 22.2 only, no, ma? But when motor runs, what happens? More amount of heat energy will go out of this refrigerator. Are you able to understand? So at what rate heat must be taken so that we maintain the same temperature of 22.2 degrees Celsius, and K value of the door is given. K value of what is this? K value of the door only, no? Through door only heat energy is exchanging. Clear, no? So this is the question which you are supposed to calculate. Can you say how can I do the calculation? Okay, ma? Anybody? So what is the equation for Q value? Q value is equals to Ka into T1 minus T2 into T divided by X. This is the relation, no? X or L, anything you can write. So first of all, let us calculate to maintain this much of temperature difference, how much heat energy should be leaving this refrigerator. Clear, nama? So Q is equals to K value is 0.05 and area of the door is already given, nama, it is 5.6 multiplied by temperature difference is how much? 22.2. And let us do the calculation for 1 second. You can do the calculation for any time. I am doing for 1 second. Clear, nama? Divided by X means what? Thickness of the door, no? What is the thickness of the door? 90 mm. 90 mm he gave, no? So means 90 into 10 power minus 3 meters. 1 mm is equals to how many meters, ma? 10 power minus 3 meters. Clear, no? So this is the amount of heat energy which should be passing. Okay. But motor is running for how much time? Motor is running only for 15% of the time. Are you able to understand, ma? So therefore, heat that should be taken out. Heat that should be taken out is how much? I have taken for 1 second, no? Calculation I have done for 1 second. But he is asking only 15% of time. Time is 1 second, no? So what is the 15% of 1 second? 15% of 1 second means 15 by 100 only, no, ma? So therefore, it should be equal to Q by T is equals to, So do this total calculation. 0.05 multiplied by 5.6 multiplied by 22.2 divided by 90 into 10 power minus 3 multiplied by 15% only, he said, no? So 15 by 100. Okay? Just do this calculation. That is my required answer. So this is the amount of heat energy that should be taken out. So this is for 1 second calculation, ma. This is the amount of heat energy traveling per second. But motor is running only for 15% of 1 second. No? Total time I am taking 1 second. Total time you can take anything. You can take 1 hour, 1 day, 1 week, anything you can take. I am taking 1 second. Are you able to understand? So therefore, motor will run only for 15% of 1 second. 15% means 15 by 100. Okay. So if you do this calculation, then you will get the amount of heat energy which should be taken out. So maintain the same temperature. And the answer for this one is, okay, ma? So 460 watts. 460 watts. So this must be the amount of energy I have to take out of the refrigerator, in which condition when motor is running. Okay, because motor will produce this much of energy when it is running. Okay, ma? So you have to take out that much of energy. Okay, but when motor is not running, you have to take this much amount of energy. Are you able to understand? And its value will be how much? It is approximately 69.1 watt. 69.1 watt. This is the energy we have to take when motor is not running. Very less energy. But when motor is running, you have to take this much energy to maintain the same temperature. Temperature difference should be constant, no? That's it. Okay. So see this question now. So water is boiled in a flask on a stove. So consider this is a flask. Okay, ma? And here we are heating this one with a stove. And water is present in this flat bottomed flask. Okay. And area of the bottom is given. Area of the bottom is 3000 centimeters square. It means it is given in CGS system. So while reading the question, data, what is the importance of data? Same will be the importance of units also. Okay. If you miss any one unit, gone. Everything is gone. Time is wasted. And beyond that, you will get negative marking also. Time waste avadam okati. వచ్చిన మార్కులు ఊసిపోతాయి అన్నమాట. సో యూనిట్స్ అండ్ డైమెన్షన్స్ ఈస్ వెరీ ఇంపార్టెంట్. క్లియర్ మా? So then thickness is given is how much? Thickness means what, ma? This bottom surface, it has a particular thickness, no? So that thickness is saying it is 2 millimeter, but it is given in millimeter, no, ma? But here it is given in centimeter. K value is also given in CGS system only. So 2 millimeter, how I can write? So 1 centimeter is equals to 10 millimeters, no? So therefore 2 into 10 power minus 1 centimeter in CGS system. Are you able to understand, no, ma? So if the amount of steam produced is 1 gram per minute, okay, amount of steam produced, he said, is m by t, no, ma? Mass per unit time. Grams means mass, time means minutes means time. So the amount of mass which is converted into steam per unit time is how much? It is 1 gram per minute. And here it is given in seconds, no? See the unit of K value, K is given in seconds. So you convert this one also in terms of seconds. 1 minute is equal to how many seconds? 60 seconds. So 1 by 60 grams per second. So this much amount of water, it is converted into steam. Are you able to understand how we are proceeding? Clear, number? Then temperature difference between inner and outer surface of the flask we are supposed to calculate. So when you are heating at the bottom, it will be at a different temperature, and inside the flask there will be inner surface, number. That inner surface will be at a different temperature. Are you able to understand? For example, if this is the flask, are you able to understand, ma? This is at a higher temperature, this one is at a lower temperature. So that temperature difference we are supposed to calculate. Are you able to understand? Now see. See, ma. So what is the amount of heat energy transferred? Do I know? So Q is equals to Ka into T1 minus T2 into T divided by X. This is the relation we have been studying, no? Okay. Everything is given, but how much heat energy we are supplying, is it given? If I know this value, then only I can calculate temperature difference, no? What he is asking us to calculate, he is asking us to calculate T1 minus T2. This one he is asking us to calculate. Are you able to understand, no? So to calculate this value, every value should be there. Q is not given. Amount of heat energy we are supplying, that is not given. So how can you calculate? Very good. Q is equals to M into L. This relation we have, no? Okay. Why we are using Q is equal to M into L? Because water is converting into steam. That's the data given, no? How much 1 by 60 grams of water it is converting into steam. So this question is based on change of state. Liquid state of water it is converting into gaseous state of water. Are you able to understand, ma? So therefore m by t is how much? I will do one thing, ma, divide both of them by t. Okay, because it is given per time, no? So I will do this also per time. So q by t is equals to, what is m by t? M by t is 1 by 60 multiplied by L. Can I write like this? M by L. M by t. Mass of water converted into steam per unit time is 1 by 60. Already we have calculated that, no? And L is latent heat of vaporization. What is the latent heat of vaporization of water? Yesterday only we have studied 540. Okay, ma? So q by t is equals to 1 by 60 multiplied by 540. So 6 and 0 get cancelled. 9 6 are 54, no, ma? So therefore q by t is equals to 9 calories per second. So this is the heat energy required to convert this much amount of water into steam. And same amount of heat energy should be supplied by stove also. Are you able to understand, ma? For water to convert into steam, I require this much energy. Same energy should be supplied by this stove also. Therefore, can't you substitute in this equation? You take this t to this side, then a q by t will be how much? Ka into T1 minus T2 divided by x. Now all values we have, no, ma? Q by T we have calculated. K value is given, area is given, x is also given. Just calculate T1 minus T2, that is my required answer. Fine? Come on. Okay. So this is the amount of heat energy required, no, ma, for converting this much amount of water into steam. Okay. So same amount of heat must be supplied by stove. Stove should supply same amount of heat energy. So just this is the heat energy required by the stove. Now that is supplied by the stove. Okay, ma? So substitute all the values. Okay. So q by t is how much? 9 calories per second. K value is how much? 0.5. All of them they are in CGS system only, no, ma? Area is how much? It is also in CGS system, 3000. Temperature difference I don't know. Okay, ma? Per second only I am doing the calculation. And what is the thickness of this flask? 2 into 10 power minus 1. Okay. So just I calculate T1 minus T2 from this one. That is my required answer. 1.2. 1.7 వచ్చిందా? 1.2 into 10 power minus 3. 1.2 into 10 power minus 3 degree Celsius. Okay, ma? So that should be the temperature difference between outer surface of the flask and inner surface of the flask. Understood, ma? See, ma? So a cubical box of thickness 8 centimeter. Okay, ma? So this is a cubical box, ma, and this will have walls, no? What is the thickness of the walls? Thickness of the walls is 8 centimeter. Okay. So the only way for heat to enter or leave the box is through the solid cylindrical metal plugs, each of area 12 centimeter square. So here there are 2 plugs, ma. Okay. So this is plug number 1, and this one is plug number 2. Okay. So heat should either enter this plug or it can leave this plug. It means the remaining surface area is there, no? From there is no loss of heat energy or there is no gain of heat energy. Only through this plugs only heat energy should enter. Okay. And here the temperature of outside of this plug, it is maintained at 100. Okay, ma? And here also second plug is there, no? Second plug also outside the temperature is maintained at 4. And inside this box there is a source of energy. Energy means there is a heater which is producing heat energy. Are you able to understand, ma? And inside this box a constant temperature should be maintained. And what is that constant temperature? Let that constant temperature is theta. And this theta value only we are supposed to calculate. That's all. That is the total meaning of this question. Are you able to understand, ma? Heat can enter from here and heat can leave from here. Okay. But in the middle there is one additional source of energy. So until now we have studied only Q is equals to Ka theta into theta 1 minus theta 2 into T divided by X. We studied only this relation. No? But here the twist is that inside this box there is a source of energy. Okay. And inside this box we have to maintain constant temperature. Therefore, what is that particular temperature that can be maintained inside that box that I am supposed to calculate? Okay. Now can you say, how can I do this calculation? Adi matram adagakanడి. Cheppandi. How can I do the calculation, my anybody? Huh? So what did I say? I said you that, okay ma, heat flow, water flow, temperature flow, that is heat energy, water energy, electric current, they behave similarly. I said you know. Now heat is entering from here. Heat, because this is at a higher temperature, no, definitely heat should travel in this direction, because 4 is at a lesser temperature. Clear, no? What is the direction of heat flow? This will be the direction of heat flow. Okay. Heat entering. Here also heat is produced, no? Heater is there, and here heat is leaving. So combinedly, how can you write a equation? Can you say? Equation of heat, how can you write? Anybody? So very simple, no? So heat entering from where? From plug number 1. Okay, ma? Plus heat produced by the heater. This heater is producing heat, no? And both of them, they should leave heat leaving. Understood, no? This I can write by law of conservation of energy also, no? What is the heat entering the system? Same heat should leave the system also. Then only constant temperature can be maintained. Avuna kada? So if heat entering is greater than heat leaving, then temperature of the inside of this bug continuously increases. Ante kada? Similarly, if heat leaving is greater than heat entering, then temperature falls down. But I have to maintain same temperature, no? If I should maintain same temperature, then this is the only method of writing the law of conservation of energy equation. The amount of heat entering plus amount of heat produced by the heater, both of them, they should leave this plug, second plug. That's all. Very simple. Is it clear? Now just substitute all the values. Clear, ma? So what is the outside temperature? 100 for first plug. And inside temperature, I don't know. I have called it as theta. Understood, ma? So Q entering, how can I write? Okay. So Q value, K into A into temperature difference is 100 minus theta multiplied by time divided by distance is x. This is the heat entering from the first plug, no? And what is the heat produced by the heater? Somewhere it is given. See this total data, 36 calories. This is the heat generated inside the box. Clear, no? So heater is producing how much heat energy? 36 calories per second. Okay. It means this one also I have to take per second only. Okay, ma? And this is equals to heat leaving. For heat leaving also again same equation I can write, no, ma? So therefore K multiplied by A multiplied by. Now what is the temperature difference between these two? Here temperature is theta, here temperature is 4. Definitely theta should be greater than 4, then only heat will go out of this box. So theta minus 4 multiplied by time taken divided by x. So this is the information, no, ma? Are able to understand how we have written? Just by using law of conservation of energy, we have written this equation. Then only temperature can be maintained. Understood, no? Now every value is given, no? K value is given. What is K value? Where is K value? This is the K value. Clear, no, ma? K value is already given, 0.5, and it is given in the calories only, CGS system, so no problem. Area. What is the area of this flux? Area is 12 centimeters square. So this is also given in CGS system, no problem. Time taken, you take it as 1 second. Okay, ma? Because here he given 36 calories per second, no? So you write in second. And what is the thickness of this each plug? Thickness is 8 centimeters. So every data is given, no? The only data which I don't know is theta. Clear, no? So just to calculate the theta value, that is my answer. That's it. Every quantity is given. Theta you are supposed to calculate. And the value which you should get is 76 degrees Celsius. Okay, ma? That is the final answer which you should get. And this calculation, I am not doing, ma. Try it and get that answer.